Okay, perfect. On commence à quelle heure? children also will sit upon your throne forever. For the Lord has selected Zion, and he has chosen her a dwelling for himself. This is my resting place forever. Here I will dwell, for I have desired it. In blessing I shall bless her hunting. Her poor I shall satisfy with bread. Her priests I shall clothe with salvation, and her saints with rejoicing shall rejoice. There I shall raise a horn to David, and I have prepared a lamb for my anointed. His enemies I shall clothe with shame, and my holiness shall flourish upon him. Alleluia. Psalm 140. O Lord, I have cried to you. Hear me. Attend to the voice of my supplication when I cry to you. Let my prayer be set forth before you as incense, and the lifting up of my hands as an evening sacrifice. O Lord, set a watch on my mouth and a strong door for my lips. Do not incline my heart to words of evil, to employ excuses for sins with men who work iniquity. And I shall not agree with their choices. The righteous shall chasten me with mercy and reprove me, but do not let the oil of a sinner anoint my head. For yet my prayers also is in their pleasures. Their mighty ones have been swallowed up near the rock. They shall hear my words, for they are delightful. As a lump of earth they are broken upon the ground. Their bones have been scattered at haze. For my eyes are to you, O Lord. O Lord, I have hoped in you. Do not take away my soul. Keep me from the snare which they have set for me, from the stumbling blocks of those who work iniquity. Sinners shall fall by their own net. I am alone until iniquity passes by. If life were everlasting and this world ever existing, you would have an excuse for my not the temptation, but deliver us from the evil one. In Christ Jesus our Lord, for thine is the kingdom, the power, and the glory forever.
Decide on one note because I can go high, but it hurts my back.
I'll just like remind you of the tune, okay?
Jesus, I have promised to serve thee to the end. Be forever near me, my master and my friend. I shall not fear Satan if thou art by my side, nor wander away if thou wilt be my guide. Guide me. Guide me, lead me every day. Let me follow all the way. My rock of salvation, thou shalt always be. I make haste and always take refuge in thee. Let me hear thee speaking in words near and still. All the storms of passion and murmurs of self-will speak to reassure me whenever I fall. Speak and make me listen, O guardian of my soul. Guide me, lead me every day. Let me follow all the way. My rock of salvation, thou shalt always be. I make haste and always take refuge in thee. Jesus, thou hast promised, all who follow thee, that in thine own glory thy servant shall be. Jesus, I have promised to serve thee to the end, so give me grace to follow my master and my friend. Guide me, lead me every day, let me follow all the way. My rock of salvation, thou shalt always be. I make haste and always take refuge in thee. Let me see my footprints in the plant my own. My hope of salvation is in thy strength alone. Guide me, call me, draw me, hold me to the end. And in heaven receive me, my master and my friend. Guide me, lead me every day. Let me follow all the way. My rock of salvation, thou shalt always be. I make haste and always take refuge in thee.
Thank you. I think it's very well to be my next favorite song. Your next after So,
Sing for us. Yeah, Mark, this is your song.
can we all sing together? Everybody knows this?
Which one?
Convention 2005.
Which one is it?
Everybody knows it?
No.
Oh, what? That's my brother's favorite song. Sing it also.
Martha's not here now, so
You want to sing this one? Just like the earth when it found its home, just like the happy dove, your house, O Lord, I love your house, I love with honesty. Your house is prayer, praise, and candles. Your house is love, light, and peace. Just as I love your house, O Lord, I love you unto the end of day. Just like the bird when it found its home, just like the happy dove, your house, O Lord, I love your house, I love with honesty. Your house is full of blessings, protected against all demons. We celebrate there the liturgies, pray for all the saints. Just like the bird when it found its home, just like the happy dove, your house, O Lord, I love your house, I love with honesty. In your house you read the Bible and learn there the nicest songs, and hear there the blessed hymns, and praise you all our lives. Just like the bird when it found its home, just like the happy dove, your house, O Lord, I love it's like somebody took it and put it in Google Translate because nothing doesn't come. It doesn't make sense. Yeah, there's no natural.
This is from Arabic.
And thirdly, a warning that we're gonna hit a high pitch would have been.
That's the key to it. We have time for one more, or should we?
I think I know that Ben is writing something from the manga, so
Yeah, like who's shepherd of my soul?
Honestly,
Are you ready?
You know how to do the notes?
No, give it to Mark.
no, go ahead. John.
I can't skip. Lord knows that he's blessed me with many things, just not a voice.
In whose presence delighteth my soul, and whom in my distress I call, my comfort by day and my refuge by night, my stronghold whenever I fall. Shepherd of my soul, I beg thee to tell where thou keepest thy sheep to rest. For why should I roam in the valley of tears and wander as one who is lost? I ask thee to tell me, daughters of Zion, have ye seen the one I adore? I seek him in vain in the night of my soul, but lo, I can find him no more. Shepherd of my soul, I beg thee to tell where thou keepest thy sheep to rest. For why should I roam in the valley of tears and wander as one who is lost? I am my beloved's, and he is mine. He calleth me sister and spouse. Oh, how do I long for the day we shall wed in heaven, in his Father's house. Shepherd of my soul, I beg thee to tell where thou keepest thy sheep to rest. For why should I roam in the valley of tears and wander as one who is lost?
Always a classic. Always a classic.
Oh, take the mic because I need to connect this. Take the mic so I can connect this. It's gonna drop. Yes. why do we have a picture of someone who is Zaid? Oh, okay, we need to turn your laptop around.
Really?
I don't think it'll. This one. Open display preference. I don't know what the password for it. The password for it. Show mirror inbox is unavailable. Not available. Is it not available? Arrangements. Mirror. No? How about if we talk to like okay, how do I close this?
Is everything okay?
Technical difficulties.
Why?
Trying to finish. الكابل انشلت.
Okay. Did you have it? Can you airplay it?
ما احنا بنحاول نعمل كده. يعني ده problem يعني لو مش هنعمل like
Okay. So shall we sing a song لغاية ما تخلصوا؟
We're good. We're good. It's good.
You don't want this? Hello, everybody. Before we begin with the lesson, just want to make a quick announcement that we will have the youth formal dinner next Sunday. If you haven't received the message, Uncle is holding up, Uncle Samir. Everybody knows Uncle Samir. Uncle, stand up, say hi, wave the flags. And by flags, I mean the tickets for next week's gala. So if you haven't purchased your ticket yet, please get them from Uncle after the lesson today. Okay, so without any further delays, I'm gonna let Uncle Fedi talk.
So everybody got one, at least? So there's a deep meaning for the topic that you're going to know about very soon. So, huh? Hold the mic? Can't hear me? Can't hear me? Better? Okay. So, I was invited to talk to you today about evolution. So I'm pretty sure that some of you might have heard that term before, either in school or university especially. How many people are in science, like in scientific programs, either at school or university or anything? 2, 3? Okay. Has this topic come before in your courses or lectures? Okay. Okay. So I just want to ask, just generally speaking, when somebody is talking to you about that topic, like a professor, for example, do they present it as a neutral subject, or do you kind of feel that there is some sort of bias towards a certain opinion or a certain point of view from the professor? What do you think? Whoever thinks there's some sort of bias or an opinion, like a hard opinion on the subject, can you raise your hand? 1, 2, 3. Okay. Whoever thinks that it's usually presented in a neutral way. Whoever doesn't understand the question. Okay. So we're basically going to talk today briefly about whether evolution is considered to be a scientific fact or a myth. I'm going to share with you a quick story that happened with me. I have a degree in biochemistry, so evolution was definitely a big part of the program in most of the courses, if not all of the courses. And one time I was asking a professor, we used to email, I was asking a question, and I kind of wanted to see what his opinion was about the matter, because I thought that this professor was a Christian. And I know that being a Christian professor in that field specifically is, it's unusual. So he seemed like a nice guy. He seemed like a very open-minded person. So I just wanted to check. So in my email, I sent him, and since evolution is just a theory, and then I continued my question. So his reply to me was all caps, and he's like, evolution is a fact. It's not a theory. And then he continued answering the question. So I stopped there a little bit. So the topic, I chose to answer the question evolution with an asterisk, which is very important. Is it science or myth? So, having said that, what we're going to talk about today briefly, just a little bit about evolution, what it is, what it means, the different kinds of evolution, if you will. Some fun facts about this theory, and then why should I care about this, or why would I care about all this stuff? I can just go on with my life, let people talk about what they want to talk about, and be good, right? So what's in it for me, kind of thing. So from the book that started this whole thing, The Origin of Species, Darwin said the following quote: "It's a truly wonderful fact that all animals and all plants throughout all time and space should be related to each other." Okay? What this means is that this monkey is eating his grandfather, this wonderful gentleman is smelling his grandmother, and that's just wrong. But you get the idea. Okay? That's basically what it matters, is that all animals, like a fly is related to an elephant, is related to a rose. That's what Darwin is saying, but when you hear about evolution, you hear about the chimp and the human, that they're related. They don't explain the broader scope of what this theory actually means, that everything is related. Okay? So, there are two meanings of evolution: microevolution and macroevolution. the definition of microevolution, micro is something small. So the definition, it's basically an adaptation that occur within the same kind of species, like the same kind of like animal or plant or whatever. So I like to call it as an adaptation. I don't like the term microevolution, but it's used, so we'll just use it for the sake of this presentation. And then macroevolution, which is the big kind of meaning to the word, is the change from one species to another. So like the change from, you know, like something to something completely different functionally, physically, and on the genetic level as well. So as an example to microevolution or an adaptation is like somebody who lives in the desert, like somewhere very hot. They adapt. So their bodies, they don't collapse when they live in that hot environment for a long period of time. You take that person, you put them in Canada, -40, and they don't do so well. But if they keep living in a cold space after a number of months or a number of years, their body starts to adapt, and then it develops some sort of tolerance towards the cold and vice versa. Okay? So the body genetically adapts to something. That's an adaptation. So if you want to call it a microevolution, you can call it that. And that's fine, that's scientific, that's proven. If you talk about macroevolution, that's different. So like this guy is saying like the old days were better, like he's struggling, right? And then the fish, which was his great-great-great-grandfather, according to the macroevolution theory, she's saying that I knew it. So that's an example of macroevolution that you usually find in your textbooks and in university, that basically one kind of animal changing into a different kind of animal. So you get the difference between micro and macro? Any questions up until this point? We're good? Good? Okay. So something else that you might see or you might hear people talk about, something called phylogenetic trees. What this means is that like as Christians, usually we, like when you are in an argument with somebody who believes in macroevolution, and you start telling them that the theory says that the human being was like a monkey. Scientifically speaking, they'll just come back to you and say, oh, you don't understand anything about evolution. The theory doesn't say that the human being had a monkey as a grandfather or as an ancestor. That's not true. They'll tell you that the human, so let me just do something fancy, that the human and the monkey had a common ancestor. And that common ancestor here gave rise to the chimp and to the human. And then that common ancestor had another common ancestor, which is here. And that second orange dot gave rise to the dog species and to the common ancestor, which gave rise to the chimp and the human, and so on and so forth. And then, so that common ancestor, that's a mystery up until this point. Right? We don't know how it looked, we don't know where it lived, we don't know how it gave rise to these different kinds of animals. But they tell you that this is the common ancestor, this is the history. So you keep going back, one common ancestor after the other, you reach something called LUCA, or the last universal common ancestor. And that's actually a scientific term that you might see in your textbooks. So how about that? Like if we want to go back and track it from the very beginning, because everything has an origin. So that last universal common ancestor is the thing that gave rise to all of these speciations. Okay? So where did that come from? That's basically a simple cell even before the DNA. So there's something called an RNA world that used to exist in like very primitive environments. And the RNA, according to the theory, came before the DNA, and that last universal common ancestor had only essentially RNA and a protein membrane in his composition. And then it evolved into different things, and it gave rise to all of these things. So where did that common ancestor come from? How did it form? Like how did this simple RNA basically give life to something? So I can talk to you like about the cell all, just give me a second. Sorry. So I'm just going to show you a quick video about a current cell and how the mechanisms work in terms of translating something as the RNA to a protein. So the proteins is basically what determines the color of your eye, your hair, whatever. That's how the mechanism works to translate something into another in just one human cell or one animal cell. And the reason or the purpose of me showing you guys this video is that in order for this to happen, like in order for this first common ancestor to exist, all of these mechanisms had to occur because that last universal common ancestor is a living thing. So you have to get life in order for it to propagate and to divide itself and then to find another life form to marry and to have kids at one point in the evolution theory. That's a good trick. How did this happen, if it all happened by chance? But I just want to show you like if the cell is simple or complex, and if it's complex, how complex it is. So I believe it's like 2 or 3 minutes. So these things that you see like walking, they're proteins in of themselves. Like there are molecular structures that would bind to the DNA and transcript it. So it's not like a cute animal that's like walking in the cell. It's actually a chemical structure. So it gets exported out of the nucleus into like some sort of another machine that binds certain amino acids following the sequence in the RNA. So that string that you have at the top is the RNA. And then there is like some shuttles that bind into specific sequences. And each of these shuttles, as you can see at the bottom, they hold a specific amino acid. And then the line that's forming at the very bottom, that's the line of amino acids that are sequential, and it forms the protein. Okay? Almost done. So when this process is finished, which is called the transcription, this string of amino acids, it goes into another machine, and then it takes a specific form, and that form is the form that provides the functionality of this protein, which determines like what function it does in terms of, like whether it's metabolism, catabolism, anabolism, whatever it does, that specific form had to be in that specific shape in order for it to function. So after it's exported, it gets attached to another shuttle, which takes it to its place of function where it, it starts providing its purpose and its role in the human body. So the purpose again of this video, although it was a little bit long, is to show you guys like how complex something as simple as, that's just one mechanism that happens in the cell. That's just one out of many. And you can see like how detailed and how precise that functionality is. And again, like the people, if you're in a scientific program, you would definitely study this on like a molecular level and a chemical level. And then you would realize how fascinating this is. So I'm not directing you into any specific direction. I'm just showing you a neutral video. That's not a Christian person who did this video. It's on YouTube. Like anybody can find it. But just approach it with an open mind and be honest. At the end of the day, if this is something that can happen, yes or no. So, moving on. Here's an important question. Is evolution based, and here again, we're talking about macroevolution. Is it based on a random chance? Yes or no? You will find people that talk about evolution and they tell you no, it happens through something called natural selection. And natural selection is not by chance. Okay, great. But you need to ask another deeper question. How does natural selection happen on a molecular level, on a genetic level? Okay? Because they would talk to you about a lion eating a gazelle. Great. But all of these things, they are predetermined genetically, right? Like if you dig deeper, they'll tell you that the lion is capable of eating the gazelle because he's faster, or the gazelle is able to escape the lion because her genetics make it faster than the lion. So everything at the end of the day boils down to the genetic of this animal, and that's what determines random selection. So now, if we bypass this objection that you're gonna probably face if you talk about this particular subject, then you get to the genetic level. So, genetic level, which leads to survival of the fittest, which leads to the whole idea of evolution or natural selection. Does that happen by random chance, yes or no? So according to the Berkeley University of California, mutations are random. So genetic mutations are random, okay? And that's a secular establishment. It's not a Christian, it's not funded by a church or the Vatican or whatever. And they acknowledge, and there is the link if you want to check out the university and check out the article, it's there. And they say that yes, mutations are random. So again, to put things in perspective, if you're talking about evolution on the bigger level, when you break it down to its very basis, it's all based on random chance. So have this in mind and remember the video that you saw. So here's a question. Can chance produce information? Because the cellular level, the DNA, the RNA, that's information. That's sequential, and it determines, like, you know, the shape of your bones, the shape of your face, the color of your hair, of your eyes. So that's information, it's not random. It's like a code on the computer, like for programmers, like you understand what a code is. It's not random, it's very precise. And to take it one step further, that information produces life, because we're all living creatures, plants, animals, birds. So if you take it as something as simple as a painting, can this painting be done like random? If you throw some paint on a canvas, can it produce something like that? Yes or no? Right answer. You'll get another chocolate at the end. I'll give you 2. Excellent. That's an excellent point, because that's what they say. They say, give it time, okay? So, if you give it time, then it will happen, right? Great, great. However, there is one tiny problem with that, if you give it time. It's something simple called the scientific method, okay? We have taken the scientific method in, what, elementary school, I believe, or something like that? They don't believe in the scientific. Okay. So what is the scientific method? It's something that's based on an observation. So you observe something in, you know, walking down the street, in the lab, whatever. You question what's behind that observation. You formulate a hypothesis, and when you formulate the hypothesis, you try to prove it by doing experiments in the lab. Then you analyze your results, and then you reach a conclusion. Evolution has a problem with 2 steps, or macroevolution, I should say, have two problems with the scientific method. Number 1, the experimentation, and number 2, the analysis. Okay? So, like, you'd see people, like, they don't understand, like, okay, how come this is true? Like, how come if I'm saying that evolution is scientific? It's a very simple statement. If something is scientific, like the gravity, for example, You put this phone here, you leave it, it falls. You can test it, you can observe it, you can detect the speed. It falls down, that's gravity. It's something that you can prove in the lab, that you observe, that you can see, that you can repeat and test, correct? Now, with macroevolution, from one common ancestor giving rise to a chimp and a human, how can you prove that in the lab? If it's something that you, by definition, you cannot see, it goes back millions of years. So they tell you it's not a theory, but in fact it is, because you can prove it in the lab. And it's something very specific, very simple, like we're not going into great details. If it follows the scientific method, great, teach it as a fact. But if it doesn't, don't call it evolution is a fact. Just call it a theory, and a dumb one at that. So it's not even like a theory worth investigating if we're honest with ourselves. Yes? Yes?
What if you do, like, the limitations are that you can't move in the lab, you have time that's there,
Mm-hmm.
and then you use like computer models to simulate it.
Man, did you see the presentation? Before?
I'm talking about
You're one slide ahead.
the presentation. We're talking about this point specifically.
Yeah. Next slide. Hmm? Can you repeat?
No, I can't. I'm gonna get attacked again.
What are you? I didn't attack
Yeah, what if? My question was specifically to the limitations of our current technology and what we're able to actually measure in the lab. Like 100 years ago, you talked about lasers and like, oh, you don't have a way to like measure laser. Maybe lasers, yes, but whatever. Other examples. 200 years ago, you couldn't measure lasers. So maybe we don't have the technology available now, but more and more as we progress through what's available, we could maybe use like simulations and data models to be able to predict, or even not just predict, but measure evolution.
I hear you. So there's two things. So that John's question basically is like, what if we don't? تعالى. Like John's question is basically like, what if we don't have, like, what if it's true, but we are limited, we can't see it right now? Like, you get the question? Like 100 years ago, if somebody spoke to you about like a laser or something, that you'd say like, this is complete fantasy, you can't prove it, you can't do anything. But then you give it 100 years, and then it's provable. I 100% agree with you. But at that point, when you can't prove it, okay? And so, number one, you can't call it a fact. You can't call it anything other than a theory, okay? If you jump off a building, are you gonna risk that this is a theory or a fact? Like you're gonna fall. Such as? Okay. Okay. That's fine. I'm just saying, like the theory of gravity, you can prove it. Okay. There are some things that you can test and prove in the lab, even if it's not gravity, if it's other things, like a chemical reaction. You can see it. You can see like if you put sodium in water, just stay a little bit back because you're not going to like what happens. But so stuff like this you can see, you can test, you can repeat, you can prove, which is the basis of the scientific method, right? When you talk about something that's unprovable at the time being, at best, to be fair, call it just a theory that's unproven.
So I actually listened to this really cool talk about evolution as well. And so actually the laws of thermodynamics, they really disprove the theory of evolution. And this specific point, I don't remember which law, but it was the law of entropy, which is the law of disorder. And so that law states that anything in the universe tends towards disorder. It never comes together. Second law of thermodynamics. So, you know, if we say, well, like going back to the painting picture, if we throw the paint out there and eventually it will turn into a really good painting, then that violates the second law of thermodynamics. So then,
Okay, so you get the scientific method point? Okay. So I want to share with you something from the lab on a molecular level. At my last year of university, I was very interested in that subject, so I decided to work in a lab that studies evolution on a molecular level, like on a genetic level, because I wanted to get to the bottom of this thing and see like what exactly is happening. Because really, like if you try to check like the fossil record, right? The fossil record doesn't really prove anything for a simple reason. If you find like a bone in the dirt, like a fossil, all you can prove is that animal died. You can't prove that this animal had any kids, let alone had different kids. Like this bone would not stand in a court of law. It wouldn't, right? All you know is that it died. So you can't use the fossil record really as proof for anything. But if you go into the genetic level, that's like the thing nowadays that evolutionists count on the most, because they present you with different, like in my example, I studied algae. So I had two different species, and the hypothesis is that we want to prove that these are related like 98%. So we analyzed their DNA, we analyzed their proteins, we extracted it, we put it in like a computer software, and then you get like a sequence of amino acids that form the protein. So you analyze it from the genome of these two species, and you want to reach the hypothesis. So as you can see, like they are kind of similar, okay? Not 100%, but the blue one at the bottom is kind of shorter. I'm just giving you a very simplified example. The greener is shorter, the gray is longer. But then something interesting happens, and that's like something that I studied firsthand, that I was working on that project. So you reach the end of the sequence, and they're completely different. So up until like the gray one, you could still follow the hypothesis. They're kind of related, they're revolving around the 98%-ish similarity. But that sequence at the end, it completely destroys the theory. Because if you're taking an average, including these two last sequences, then your probability of a 98% similarity drops significantly, like in the 70s. So, what do we do? I had this issue, I went to my supervisor, I went to my professor, and I was like, here are the two sequences, I'm running into this issue. What next? What's the next step? And what he said, like, I'll never, ever forget this. He's like, let's just cut these two sequences and neglect them from the analysis. Don't mention it in the results or the discussion. So I'm like, well, they're a part of the sequence. Like they're not extra, like something else from a different species. They're from the same animal, like from the same algae. And he's like, no, that's fine. So I was like, at this point, I gave him the benefit of the doubt. I was like, okay, not gonna mention it in the report. However, can I at least put like an addendum at the end, or like in the references, in like any other point in the report, like in the article, to present that due to A, B, C, D, we had to remove these two sequences from these two algae in order because of 1, 2, 3, 4. Like that's how science works. Like you present honestly what you're doing, and the results that you get are the results you get. So then he's like, no, there's no need to do that because everybody does it. Like seriously. And at this point, I was a bit, to be honest with you, like I was a bit concerned, like I was kind of on the fence when it comes to the genetic level, because genetics, it's like numbers. Numbers don't lie. The same thing happened here, which is like, if it messes with your theory, then don't talk about it. That's essentially my own experience. You might have different experiences, but in that lab, that's what happened. I can give you the name of the professor. He is very well published in Europe and in Canada, North America. So that was my own experience from the lab when you talk about the genetic side of things. So moving on to fun facts. After this cool animation, hopefully it does something. So there is something called the polystrate trees. When you look at the geologic column, it's basically different types of strata, different types of rocks, and they date like for millions of years, right? So the one at the top is like older or younger than the one at the bottom, and so on and so forth. So here's a question for you. What if you find a single tree, a petrified tree, like this one in Nova Scotia actually, and it's connecting multiple layers of these rocks, and each layer is supposed to have lasted like millions and millions of years? What does that prove to you? And these polystrate trees or petrified trees are found all over the world. So does that prove to you, like how long does a dead tree is still standing? Does it still stand? Does it stand for like 5 days, 10 days, a year, 2 months, a million years? It falls apart and it decays pretty quickly. So what that fun fact proves is that maybe, just maybe, there was an event that happened, a very rapid event, that caused this tree to be uprooted from its root and like thrown and basically connecting all of these layers together. An event such, okay. So if you have different layers, okay, of rocks, one under the other, and the geologic column tells you that layer number 1 happened like 5 million years ago. Layer number 2, the theory of erosion, it happened, it's older, so it happened 10 million years ago. The one underneath it, 15 million years ago. So these are supposed to be different eras, right? But from what we can see in these pictures is that you have one single tree connecting all of, like standing vertically, connecting all of these layers together. Like the bottom of the tree is in layer number 1, the middle is in layer number 2, and the top is in layer number 3. So it's one tree connecting like 3 types of layers, which were supposed to be like 15 million years ago. So how can a single tree be standing there 15 million years ago? Unless these layers happened very quickly by erosion. For example, when the flood happened. So the water, like according to the Bible, the water, it basically just, it fell very quickly, and that might have caused this tree to be uprooted and to be thrust into these layers in the first place. And then when like the water fell, when the water cleared, all of these things erode. Like you take a glass of water, you put some sand, some rock, some minerals in it, and you shake it and you let it clear. You're gonna find layers, right? So that's a theory that how this tree is standing still. So that defies like the millions of years in these rocks. Do you guys get it?
So you're saying that these layers aren't actually...
I'm just asking the question, like how come you can, because this thing is not, it's not like an imagination. Like you can see these trees, you know, like in different areas in the world. So I'm just asking the question, how come you have one tree standing still for 15 million years, or even longer than that? Unless there is another explanation about these rocks. Maybe these rocks are not that old. Otherwise, you wouldn't have a tree connecting all of them.
Well, to be fair, I mean, dead trees can, dead trees can probably stand for a while.
They can, but for how many? For how much time? Not millions of years. Like you can see a tree that, like a dead tree, it doesn't stay in its place for 15 million years, right? Number two, there are some limitations to dating methods. So, for example, and that's in the Science magazine. So, fun fact is that shells from living snails, were carbon dated as being 27,000 years old. If they're living snails, right? Like your hair, for example, would be 15 million years ago, and you're still living. That doesn't make sense. What? Okay. Okay. So there are some limitations to carbon dating and to different dating methods. Like they work within a certain time frame, but you can't use a same dating method to date something that's going to be older than what it can do. Yes? So the basis of carbon dating, or they call it radioactive decay, is that let's say I give you a candle and I light up the candle, you see it burn, okay? What can you tell me from this? You can tell me how fast, based on your observation, how fast is the burning happening and in how much time this candle is going to be completely gone, right? But can you tell me when was this candle lit? You can't, right? So that's one of the limitations of carbon dating. Like they take a piece of, or radioactive dating in general, they take a piece of something and then they analyze the carbon decay, the rate of carbon decay in it, and then they trace it back. But it's not accurate. It's an approximation. And then there are some certain research that was done that it doesn't work for more than 33,000 years. So by definition, if you find something that dates more than 30,000 years or 33,000 years, you question it. You can't be sure 100%. Another answer to your question mark is that question mark. Sorry. Is that there are some, like the age of the Earth itself. The more they date it, the more they try to measure it. It varies. So you can't be sure 100% because you measure it with one method, you get a number, you measure it with another method, you get a different number, and so on and so forth. So again, if it passes that threshold of 33,000 years, I believe, don't quote me on it, you can't trust the number. I know. It doesn't, it's not accurate. It's not accurate to start with, and after that, you can't trust it. So, moving on to some of the lies that are present in our modern textbooks. And you might have seen this drawing before. Anybody has seen this drawing before? No? Okay. So, the one at the top was made by a researcher called Haeckel. He's basically trying to prove that all or most of the living species are kind of similar. So he tracks them in how they look in the prenatal stages, and then he drew them and presented his theory in universities and stuff like that, and then it was debunked later on in 1997, I believe. And the one at the top is the drawings that he fabricated. The one at the bottom, when we have access to microscopy and very accurate and honest data, this is how they really look like, you know? So there is quite the difference in the real life versus the one that he drew. So that's a fabrication that he made in order to convince students with his theory or with his point of view. And unfortunately, that's still being taught in our modern textbooks. You see, these are references of modern textbook dating to 2013. And that theory is still being taught as a fact, which is which is sad, to be honest with you. So, moving on. Now, here's something. You have a coffee crisp and you have a Rolo, right? Both of them are kind of rectangular in shape. They have 4 angles. They taste sweet. They're crunchy. But it doesn't mean that they evolved from a Kit Kat 15 million years ago. It means that they have a common designer, which is Nestle in this case, versus a common ancestor. And you see where this is going, right? So maybe there's something called a common designer versus a common ancestor. Just going to leave you with this thought. So, why should I care about all of this? There's a quote from Dr. House, says if you could reason with religious people, there would be no religious people, okay? And that's the kind of thing that you're gonna see, or if you ever get into a discussion like this, you're gonna get that kind of ridicule and that kind of, oh, you're religious, you believe in creation, you believe in the Bible, like you're stupid kind of thing, right? So if that's the case, all of these scientists, they are believers, okay? They had some sort of belief, and still they, like, their inventions and their achievements we still use to this day, so we owe them. So we can't just dismiss everything based on, yeah, if you believe in the Bible, then you're stupid. Like that in itself is kind of a stupid statement, right? Another thing that you might hear about is the theory called the God of the gaps. It's basically an evolutionist or an atheist telling you, yeah, if you're a Christian or if you're a believer, then you're intellectually lazy, right? Because whenever you have something in science that you don't understand or that you can't prove, instead of doing your research and instead of going and studying and you just say, oh, God did it. So they call this the God of the gaps, right? Which we don't use. We say that we go by the scientific method at the time that we're living. If this thing conforms to the scientific method, we call it science. If it doesn't, we don't call it science. It's as simple as that. But this doesn't mean that we stop researching and we stop like thinking. On the contrary, like we saw, there are many scientists until this day that are Christian believers. So again, that's another tactic that they use. And then the other thing why we should care about that is that if we are animals, like the theory says, then really what is right and wrong? What is morality? What determines morality? If you ask a person that firmly believes in the theory, like a firm believer in evolution, they would tell you that society is what determines morality. Morality is relevant. There is no right and wrong. It depends on the society. So if a society says that killing, killing a person is right or raping is right, then if the society says so, then to the society it's right. The problem with this is that they say that there is no absolute right and wrong, like we say, like the Bible says. So that's another issue of why this theory has some philosophical implications and some implications that happen like in the day-to-day. If really morality is relevant and there's no absolute source for it, then who is to say what's right and wrong? So what is our Christian standpoint about this? It's very simple. It's basically we have no problem with adaptation or microevolution. That happens, we can see it, we can test it, that's science, that's fine. We believe in the scientific method as the base of modern research. We're not against research, we're just against lies. And we are against lies or personal philosophies presented in the form of science to promote a certain agenda or a certain point of view. Another question is, can I believe in both? Can I be a Christian? Can I be a believer, a Christian, and believe in a Darwinian evolution at the same time? I'm going to answer. I'm just going to present you some ideas, and you determine. So, the Bible says, essentially, man brought death into the world, right? After the first sin, everything started to decay. Death was presented in the world after the sin. So, in a sense, it's man who brought death in the world. Evolution says the other way. It's death who brought man in the world. Natural selection is you give it millions of years through the survival of the fittest. That's what brought man in its current shape and form into the world. So philosophically speaking, there is a difference. Something as simple as the creation story versus the evolution theory. In the Bible, in the creation story, birds were created before dinosaurs. In the evolution theory, dinosaurs evolved into birds. So it's the other way around. As Christians, we believe that humans are not animals. Like, there's a purpose to our lives. That's our belief system as Christians, what the Bible tells us. And evolution says humans are indeed animals. So again, there's a purpose to our life according to the Bible. There is no ultimate purpose to life according to evolution. At best, it's to propagate your genes. As in genetics, not like a pair of genes. Making things clear. Yes. Yes. As animals. Actually, it does. In the book of Job, it mentions a creature called Leviathan, which is actually a fire-breathing dragon. Yes. But if you look at dinosaurs as if they're animals, like they're kind of an animal too, right? So at the end, this is a quote from Sir Julian Huxley, who was an evolutionary biologist, and he was one of the founders of the UNESCO, which is one of the well-established secular scientific institutions. And I like this quote because this guy was honest. Like, there is nothing that would have prompted him to say this except the truth, right? So he said, I suppose the reason, and this, again, this is an evolutionary biologist. I suppose the reason why we leapt at the origin of species, which is Darwin's book, was the idea of God interfered with our sexual mores. So he basically, and he said it like it is, right? Like, we want to live in a certain lifestyle, and the idea of special creation interferes with that. So we reject it, we jump to the origin of species because it's a cop-out, essentially. All of this, I'd like to just end by like what the Bible teaches us, that God saw everything that he had made. So the Bible tells us that God indeed had made everything, and indeed it was very good. So, any questions? Any concerns? Any comments? Yeah, go ahead.
I was going to say, rumor has it that Darwin lost his kids before coming up with the theory of evolution. And I guess this gives him a motive to discredit God.
I don't know if it's true. I mean, the fact is that he lost his child, his daughter. But I can't say whether or not this triggered him into coming up with that idea. But actually he was like in England they have like institutions that you go through to become like a priest, and he was in one of those institutions. Like, his goal was to become a priest. He had a daughter. Yeah. He wasn't a priest. Like, he wanted to become a priest, and then his daughter died, and the rest of history. Anything else? Any comments? We're good? Mark? تقول يعني ما تتكسفش. Doctor, you want to say anything?
So the ticket is $20. Okay. So if anyone has cash on them today, just give me the money and take a ticket, or take the tickets and just like transfer the money, e-transfer, You can e-transfer to Mariam. She said some people already started to e-transfer to her. Can you receive by e-transfer as well? Or Jan? So Jan is here.